Mark, so we'll go ahead and get going on the session here for driving the future of transportation in a changing landscape of advanced fuels and technologies. We have a wonderful panel of speakers to touch on the various aspects of this topic today. I'm looking forward to a great session. And before I introduce our speakers, I'd like to go over a little bit of housekeeping items. For anybody who is here and would like to connect to the Wi-Fi, the code for attendees is RIC, all capital, RIC 2025. So again, the code for attendees is RIC 2025 if you'd like to hook up to the Wi-Fi. It's important that you be connected because we are taking all of our Q's and A's for this session through the QR code that you see up on the screen. So if you take your camera and point it at the QR code, hopefully everybody is familiar with the technology, you'll go to our Q&A portal. For those of you in the session room, go ahead and scan this QR code. And for those of you who are joining virtually, you should be seeing a box to the right of your screen with tabs for electronic Q&A and feedback. We do not have any live polling for this session. So all the questions that we get from either people in the room who are using the QR code or people who are participating virtually will go into the same system. And we'll do our best to get to all the questions that we receive. We normally get more questions than we have time allotted to answer, but we will try to address all the questions that we get today. All right. We're always interested in feedback in all of our public meetings that we do as the Nuclear Regulatory Commission. So when we close the session, I invite everybody to take a minute to share your thoughts and insights. There will be a QR code for you to scan for that purpose as well, for those of you in the room. So all right, let's get to it. Our first speaker will be Brian Wagner, sitting directly to my left. He is a reliability and risk analyst in the Office of Nuclear Material Safety and Safeguards at the NRC. He's been with us since 2007 and specializes in topics related to risk-informing spent fuel storage and transportation. In his previous position in the Office of Regulatory Research at the NRC, he served as the task lead for the spent fuel pool and dry cask portions of the comprehensive site-wide Level 3 PRA project. So he's no stranger to the back end of the fuel cycle. He has a bachelor's and master's degrees in nuclear engineering from the University of Michigan. Directly to Brian's left is Matt Sumrall. He is a health physicist at the U.S. Department of Transportation in the Pipeline and Hazardous Materials Safety Administration's Radioactive Materials Division. Matt represents DOT in numerous radiation safety interagency groups and as an expert in the U.S. delegation at the IAEA's Transport Safety Standards Committee, also known as TRANSC. He's currently acting in a detail position as the Senior Policy Advisor to the PHMSA Hazardous Materials Safety Office's Deputy Associate Administrator. Matt has over 16 years of experience in radiation safety, is a certified health physicist, and earned a Bachelor of Science degree in nuclear engineering from Texas A&M University. And to Matt's left is Dr. Erica Bickford. She is the director of the Office of Storage and Transportation within the U.S. Department of Energy and the Office of Nuclear Energy's Office of Spent Fuel and High-Level Waste Disposition. She is responsible for planning, policy, and implementation of a federal consolidated interim storage facility for commercial spent nuclear fuel, including associated large-scale transportation, as well as spent nuclear fuel storage and transportation research and development. She previously led the program's work on consent-based siting, and for 7 years, she's led the program's work to assess operational considerations for future large-scale spent nuclear fuel transport, alongside intergovernmental engagement with tribal, state, and federal entities on DOE's transportation plans. Dr. Bickford has a PhD and Master's of Science from the University of Wisconsin-Madison and a bachelor's degree from the University of Maine. And last but certainly not least, at the end of the table is Prakash Narayanan. He is the Chief Technical Officer for Rano TN Americas. In this role, over the past 5 years, he is responsible to provide technical direction on our Rano TN products and technologies. He is also responsible for design and fabrication engineering, licensing, R&D, and intellectual property management. Prakash has over 25 years of experience working in the nuclear industry, including 24 years at TN with specialization in the development of licensing methods for criticality and shielding analysis, particularly burn-up credit for transportation. Prakash obtained his master's degree in nuclear engineering from the North Carolina State University in 1999. Please join me in welcoming these speakers, and I'd like to welcome all of you to the session today. And with that, I will turn it over to Brian Wagner.
Bring the mic here.
Go for it.
Hi, as Shane mentioned, I'm Brian Wagner. I'm a reliability and risk analyst in the Division of Fuel Management at the NRC. Okay, so here's an overview of what I'm going to talk about. I'm going to cover the certification process, which provides the infrastructure for regulating transportation package designs. I'll briefly go over the details of that. The requirements for Part 71 are somewhat prescriptive, so risk-informed methodology can be helpful for exemption requests, which is part of that regulation, with appropriate justifications. And in one case, the NRC endorsed a methodology developed by Pacific Northwest National Laboratory for the Project Pele transportable microreactor, and that's documented in SECI 240062. And I'll also briefly talk about what we're doing in the area of new fuels. So just to give a sense of the scope here for the Project Pele effort, the life cycle of the microreactor is fabrication in a factory, transportation to the development site, operation at the development site, transportation from the development site, and decommissioning or refurbishment of the reactor. And the methodology is really focused on transportation from the site, but it could probably pretty easily be extended to transportation to the site. So I'm just going to give a brief overview of our certification process for transportation packages. The NRC regulates transportation packages in terms of both safety and security, safety and safeguards. So we think communication is a key part of the regulatory process. We encourage early engagement from potential applicants. This helps us discuss submittal timeframes, helps us understand what's in the submittal, and helps us identify and start to resolve technical issues that could pop up during the review, which is particularly important if they're more novel issues. The next step is submittal of the application. Once that's received and entered into ADAMS, we assign a project manager and a team to review the application. If the application includes sufficient information to perform a detailed technical review, that's part of the acceptance review, then we move on to the detailed technical review. And we do that using the regulations in Part 71 and the guidance that we've established. That's to ensure that the activities are both safe and secure. We focus our review on confinement, shielding, and criticality. We consider both normal and accident conditions. And the purpose of the review is to ensure that it complies with all NRC regulations, all applicable NRC regulations. If the pertinent regulations are satisfied, we issue the final safety evaluation and the certificate of compliance. That's good for up to 5 years and can be renewed in 5-year increments. And after the certification process, we inspect to ensure compliance. And I meant to mention that the certificate of compliance, COC, we call them, that includes the conditions for legally using the package. So the regulations spell out a number of package performance tests and conditions. There's conditions for normal conditions of transport. Those are laid out in 10 CFR 7171. That includes things we expect to see like hot and cold temperatures, pressures, vibrations, water spray, small drops, penetration tests. And in those cases, the regulations require no dispersal of material or increase in radiation levels. They also spell out hypothetical accident conditions. That's in 10 CFR 7173. That's more severe drops, 30-foot drop test, a 40-inch puncture test, an engulfing fire, and a water immersion test. And in those cases, a limited increase in dose is acceptable, but it must be limited. Okay, so what is Project Pele? The goal is to fabricate a transportable microreactor that produces less than 5 megawatts of power and can operate for 3 years, 3 or more years. And it comes in multiple modules, but the reactor module needs to fit in a single custom-developed international organization for standardization container, which resembles a Container Express Connex box, so a kind of standard container that's used. So why does that need a risk methodology? Why are we developing a risk methodology for this? I mostly covered a lot of this, but there's hypothetical accident conditions that they need to meet, and after those accident conditions, they need to meet certain dose criteria, and those can be perhaps challenging given the constraints of the Project Pele, particularly the shielding, cooling time. To fit in that standard container is somewhat limiting. So it may require using alternate test criteria as allowed by 10 CFR 7141C, or exemptions from specific requirements that's allowed by 7112. And the idea is to develop a risk-informed framework, risk-informed methodology to provide justification for granting those exemptions from specific requirements. And exemptions was the path they went with. So what is the risk-informed methodology? It consists of risk evaluation guidelines and a systematic process to develop a probabilistic risk assessment. The risk evaluation guidelines are frequency consequence plots that are used as surrogate guidelines to establish what the acceptable level of risk is for the bounding representative accidents, the accident sequences. These guidelines were developed informed by existing criteria that NRC has for nuclear fuel facilities, that DOE has for nuclear facilities, and that the International Atomic Energy Agency uses. And it's consistent with things we've done in other areas, similar risk-informed performance-based approaches that the NRC has previously endorsed, such as those described in Regulatory Guide 1.233, which is in case you're familiar with it, the Licensing Modernization Project, which is for non-LWRs. And the second part of the risk-informed methodology is to perform a probabilistic risk assessment to identify and evaluate the bounding representative accidents and to compare the risk of those accidents to the established guidelines. The goal is to inform package design and identify the need for any compensatory measures. So this has the elements found in the PRA. I'm not going to go over all these. It's just we expect to see all the normal good PRA stuff that we typically see in PRAs. So things like identifying hazards, evaluating hazards, determining accident likelihoods, consequences, as well as performing sensitivity analysis, uncertainty analysis, and considering defense in depth. So the guidelines themselves are shown here. The one on the left is for the public. The one on the right is for workers. They're similar, other than the one for the public is a little more restrictive. There are frequency consequence curves. The x-axis is consequence, y-axis is frequency. So you have lower risk on the bottom left, high risk on the top right. And the accident sequences are acceptable if they're in the shaded area, which is below the solid line, and unacceptable if they're outside of the shaded area in the high risk section. Also shown, the dashed line is what's used for the licensing modernization project. So you can see that the guidelines established here are somewhat more restrictive than those. So just a quick word about what we're doing in the area of new fuels. We're continuously evaluating the framework for information needs for transport and also the back end of the fuel cycle. That includes things like critical experiments, code validations, evaluating source terms, criticality and shielding, looking at thermal and material performance. And while we're focused on solving the technical issues, we're also open to using flexible approaches and risk informations in that area. In conclusion, the NRC is committed to the safe, secure, and efficient transportation of radioactive materials. A risk-informed methodology can provide the necessary justification for approving exemptions for transportable nuclear power plants for domestic use. And the transportation regulations in 10 CFR Part 71 are adequate to approve transportation package designs for new fuels and microreactors. But we're also open to using risk-informed approaches. And that's it.
Thank you, Brian.
We're turning this off, we're just being quiet.
Oh, no. Thank you, Brian. And Matt, you're up next.
Good morning, everyone. Thank you for the introduction and opportunity to be here. My name is Matt Summerall. As Shana mentioned, I work at the Department of Transportation's Pipeline and Hazardous Materials Safety Administration. My goal today is to just give you a general overview of where DOT fits into the transportation of nuclear materials. So let's go ahead. I do have a quick disclaimer, just saying basically I'm up here representing DOT and PHMSA, but the views expressed are my own and not necessarily dictating anything that is, exceeding anything legal, any legal requirements or anything like that. First, just a general overview of the Department of Transportation. So the Department of Transportation is comprised of 9 operating administrations covering all modes of transportation. Most are typically specific to a specific mode of transportation. So for instance, the FAA, Federal Highway, Federal Motor Carriers, Federal Rail, each one of those is mode specific. But down at the bottom right, you can see our little icon for the Pipeline and Hazardous Materials Safety Administration, which is also called PHMSA. PHMSA is a cross-mode administration that covers all transportation of hazardous materials across all modes of transportation. You can see here our mission statement, but the main thing is that we establish national policy, set and enforce standards. We educate and conduct research to prevent incidents, and we also help prepare public and first responders for incidences or for consequences in case an incident does occur. So where does our regulatory authority come from? Title 49 of the U.S. Code, Chapter 51, grants the Secretary of Transportation the authority to regulate transportation in commerce of all hazardous materials, specifically including radioactive materials. So that's a big part of it. The DOT Secretary has designated PHMSA to lead that effort, and we do so primarily through what we call the Hazardous Materials Regulations, or the HMR. That is Title 49 of the Code of Federal Regulations 171 through 180. We also have a long-standing agreement between ourselves and NRC going back to 1979, a memorandum of understanding between our two agencies that really kind of outlines how we co-regulate the transportation of radioactive materials. One other quick thing to say is that I mentioned that it's transportation in commerce, so that specifically does not apply to federal agencies or state or local agencies. However, many of those do actually incorporate the HMR into their own regulations or reference it so that they are still trying to abide by those regulations and requirements. Here's a few examples that you can see. DOE specifically points back to the HMR in several cases. Coast Guard, Department of Homeland Security, even NASA relates to it in a few different ways, and then NRC and PHMSA go back and forth. That should really be an arrow between the two of us for that one. So moving on, let's see. So I talked about that memorandum of understanding. I just want to go through a few of the basics of that, how again we kind of delineate between the responsibilities, between the NRC and DOT for RAM transportation. The NRC, and this goes back to some of the things that Brian just mentioned, developed safety standards for Type B and fissile packages, specifically regarding a number of very technical specifications that go into it. whereas we develop the overall safety standards for the classification of RAM, so deciding which category it falls into, the design and performance requirements for Type A packages. And just real quick, I mentioned Type A and Type B. There's a table in both of our regulations that list of A values that is a specific concentration. It's isotope specific. That if you're below that activity, then you are in a Type A package or below, or if you're above, you're in a Type B package. So when I talk about that, that's where that comes from. We also set the standards and requirements for low specific activity and surface contaminated objects. We set the external radiation field, dose rate requirements, labeling, placarding, marking. We have training requirements for personnel and carriers, and basically anything else that's not covered by the Nuclear Regulatory Commission falls into our category. A few other things, the NRC approves all domestic Type B packages, and again, emphasis on the domestic and fissile packages, and reviews international Type B packages when DOT asks them to. So we, on the other hand, do the international side, or we're at least the point of contact for the international side. I'll talk about that more in a bit, but we often do rely on the NRC to review and approve the packages even for import and export for international. The NRC requires licensees to comply with DOT regulations even when they're not otherwise applicable. So sometimes things that are happening on a site, an NRC site, is actually required to follow DOT regulations, even though that's not technically in commerce. So there's some connection there. DOT is the national competent authority for IAEA regulations, so for the safe transport of radioactive materials with NRC support. And again, I'll talk about that in a little bit, but we do issue IAEA certificates of competent authority for packages, special form sources, and special arrangements. Whereas, as Brian mentioned, the NRC issues the certificates of compliance for Type B and Type A fissile packages. The biggest part is that we overall work together a lot, mutually assist and share information for inspections, for enforcement, for accidents and investigations, and just overall exchange of information. Hardly a week goes by where our office is not contacting someone at the NRC or vice versa. It's a really good, tight-knit working relationship that I think we very openly share information and work together to make sure that overall we're helping with the U.S. transportation of radioactive material. So I mentioned, again, we are the international competent authority at the IAEA for the transport of radioactive material. That's a designation from the U.S. Department of State that DOT will serve in that role. So we go to the Transport Safety Standards Committee at the IAEA in Vienna and represent the U.S. there, which is where the SSR 6, which is the regulations for the safe transport of radioactive material at the international level, that's where that regulation is developed and modified and everything else. NRC is also there as well, and in fact, right now, for the past several years, the NRC has been the chair of TRANSC, and then the U.S. is still, and then DOT has still been the U.S. representative representing the U.S. Thoughts and opinions there. We, as I mentioned earlier, issue package certifications for the import and export of Type B packages. So if someone's trying to bring a Type B package into the U.S. or wants to export out of the U.S., they come to us. They make a formal request, then we often work with the NRC to get that review approved and then go back and forth, and then we issue the IAEA Certificate of Competent Authority. For special form certifications, that's requested directly to us, so we certify a package as special form. It's not specifically required for domestic purposes, but it is required for international purposes, and same thing for special arrangements. So where does all this fit into this talk of microreactors and the future of nuclear? In general, we hope and expect that everyone will abide by the regulations as they're required. But we recognize that there's times where either our regulations haven't been updated in a timely fashion, or there's new technologies being developed that things need to change. And so yeah, is that working? Yeah. Sorry, something bumped it. DOT special permits are one of the tools that we have available to handle circumstances outside of the HMR. So an applicant can come to us, request a special permit to deviate from the regulations. They should have a justification of either an equivalent level of safety or a strong case to make for that it's in the public's interest to do this. And so they make the application, there's specific requirements to do so, and then we can issue a special permit that allows a specific either one-time use or ongoing use to deviate from the regulations. At the international level, we can do special arrangements that, same thing, import and export. It's similar to a special permit, but it's a representative as the U.S. competent authority to the IEA. And then we also recognize that the NRC does special package authorizations. There's some that are environmental only that would not apply to us, and you would still need a special permit. And then there's others that the more general special package authorization from NRC does apply. And so if you have one of those from the NRC, that automatically works within our regulations as well. So those are some of the overall tools that we have available. I know we're going to get to questions in a minute, so that's all I have.
Thank you, Matt. All right, and we will take all the questions at the end. So Erica, you are up next.
Good morning, everyone, and thanks for the invitation to speak on this panel. I'll be talking about what the Department of Energy is doing to prepare for future large-scale transportation of spent nuclear fuel, but I did want to start first with a safety message, which is something our organization does routinely now based on experience I had last weekend. I was riding my bicycle home from brunch with friends, and 4 blocks from my house, I turned into a side street, and a vehicle pulled out, crossed the center lane, and in order to avoid colliding with the vehicle, I braked, and my bicycle stopped faster than I did. And so I met the pavement, but luckily I was wearing a helmet, and so minor injuries, no broken bones, a little bit of a cut from my sunglasses, and a badly bruised knee, but otherwise, totally fine. So just a reminder that, even when you're riding a bicycle in your neighborhood, if you're operating on infrastructure with other vehicles that may operate unpredictably, it's a good idea to wear a helmet. All right, so now on to transportation of spent nuclear fuel. This is our standard disclaimer. I think the slides will be made available, so I'll leave folks to read that on their own. So I am the director of the Office of Storage and Transportation within the Office of Spent Fuel and High-Level Waste Disposition, which is within the Office of Nuclear Energy, but I like to do offices within offices within offices at DOE. And the mission of the Office of Spent Fuel and High-Level Waste Disposition is to develop and implement a plan for the safe and secure long-term management of the nation's spent nuclear fuel and high-level radioactive waste. And that is what we're currently working on. What sort of at a high level that plan looks like is something that we call an integrated waste management system with core components of storage and disposal facilities, a transportation capability, and a siting capability. So my office is responsible for the storage and transportation capability. We're focused on designing currently a federal consolidated interim storage facility and developing the transportation infrastructure to transport commercial spent nuclear fuel to that facility. I have parallel offices that are working on disposal research and development and working on siting facilities. Some recent updates from my office and what we're doing. Last May, we passed a significant milestone for the Federal Consolidated Interim Storage Facility. This project is being conducted under what the Department of Energy's Order 413 for capital acquisition. It's a very prescriptive process that has several sort of gates that you have to pass through, and we passed through the first gate last May. With approval of what's called critical decision 0, which is approval of mission need. So the department, through the Department of Energy's Energy System Acquisition Advisory Board, approved or agreed that there is a mission need for a federal consolidated interim storage facility, and the department should pursue that project. And so that's where that was a significant step for the department in moving towards a federal consolidated interim storage facility. I'll talk more about the specifics in a moment, but our current estimates is to have the facility to begin operations as soon as 2038. So that's dependent on a number of factors. Another update in the storage and transportation world. Last June, our Atlas Railcar Consist, and a consist is just the industry, the sector term for a full train of multiple rail cars constitutes a consist. Our 12-axle cast-carrying rail car called Atlas, 2 buffer rail cars, and a rail escort vehicle were all certified by the Association of American Railroads for use in North America. The AAR is the standard-setting organization for freight transport, so that's significant. So now we have a transportation capability to move spent nuclear fuel by rail using a certified railcar consist. For the federal CISF, we have a reference concept design, and this is subject to review and approval by the administration. The reference design is cask on a pad, though we have had discussions about possibly putting an enclosed facility if we should site a facility in a northern climate that has to deal with snow and things like that. Our plan is to initially license the facility for 15,000 metric tons of spent nuclear fuel. That would enable the site to store all of the spent nuclear fuel at the 20 currently shut down nuclear power plant sites. And the footprint would be cited to have options to expand to up to 70,000 metric tons of spent nuclear fuel. We intend for this facility to be licensed by NRC under 10 CFR Part 72. And the current plan for operations is initially to start transporting at about 500 metric tons a year and ramp up to a steady state shipping rate of 3,000 metric tons a year, possibly going to 4,500 metric tons a year of transport, but we need to validate that that's going to be feasible. It's possible that there could be limitations on the loading side at the nuclear power plant sites. And so that's significant because if you look at that 70,000 metric tons, if we're transporting 3,000 metric tons a year, that's on the order of 25, 30 years that you're going to be transporting spent nuclear fuel. And then eventually we'll have a repository and continue transporting to that repository. And so that's a sense of scale that a lot of people often don't realize until it's pointed out. And so we'll need a transportation system, and what that transportation system will need, and this is not a all-inclusive list, but we have to acquire rail cars and Type B packages for transport. We'll have to stand up an armed courier program to have armed guards escorting every shipment as required by regulation. We'll have to develop standard operating procedures and training requirements for those armed guards. We'll be developing training and technical assistance programs for public safety officials in state and tribal governments along transportation routes. We'll develop site-specific transportation plans as we get closer to shipping from a site, and maybe need to do infrastructure upgrades near nuclear power plant sites. If there's rail that's in need of refurbishment, or if it's a heavy haul operation, there may need to be either temporary or permanent infrastructure improvements to accommodate the size and weight of the packages being moved. Before we get to operating a consolidated interim storage facility, though, we recognize that there's a lot of public perception out there that transporting spent nuclear fuel or any radioactive material is extremely dangerous and risky. Particularly with our plans to transport by rail, any high-profile rail derailment incident, especially those involving hazardous materials, tend to kind of fuel that concern. People extrapolate incidents like we saw in East Palestine, Ohio a couple years ago to what if that had included radioactive material, there would be radioactive contamination everywhere. Now, those of us who work in this space understand the robustness of a Type B package, but that's not something that the general public understands. And trying to explain finite element analysis and testing requirements under 10 CFR Part 71 doesn't go very far. So based on what we've seen in other countries, notably the UK, in the 1980s, they did their Operation Smash Hit, 100-mile-an-hour locomotive smashed into one of they call them flasks there, live on the BBC. Went a long way towards overcoming public concerns on the safety of transporting this material, and they've been transporting ever since and have a very robust safety record. So this is the inspiration for our plans to conduct what's now called a package performance project. I have to give credit to NRC, who originated this idea as a package performance study back in the late 90s. Doing this has been endorsed by the National Academy of Sciences in their 2006 Going the Distance report and by the Blue Ribbon Commission in their 2012 final report. So this project has gone by a variety of names over the decades, but right now it's the Package Performance Project. And I want to be clear that the motivation for DOE pursuing this project is really to build public trust and safety in the transport of spent nuclear fuel. We're going to be transporting through many state, tribal, local community jurisdictions for many decades. One of the things that we think can reduce the risk to reaching the intended operations of the consolidated interim storage facility is being proactive about addressing the concerns that we've heard. There's no intention for us to duplicate or step on the toes of NRC and their regulatory role in certifying Type B packages. We have every trust and confidence in NRC's certification process. This is really geared towards public trust and safety. But we do recognize that there may be opportunities to gather data which could have mutual benefit, and so we're looking at those opportunities as well. We intend to issue an RFP for this project later this year. The schedule is a little up in the air right now given all the changes we're seeing. Additionally, other transport activities is we are currently making preparations to ship what's called the high burnup research casks. So this is a TN32B cask pictured here at the North Anna nuclear generating site near Mineral, Virginia. This is a research project started in 2014 as a collaboration between DOE and the Electric Power Research Institute. It's for research purposes on the performance of high burnup fuel in storage and transportation. The next phase of this project is to transport the casks to a DOE research facility for continued R&D, including opening the cask and examining the fuel in the future. We're planning to ship this cask in fall of 2027 and should be announcing the intended destination for this cask very shortly. So be on the lookout for that. That'll give us an opportunity to start building our transportation capability for spent nuclear fuel, start working with our state and tribal partners, and see a live shipment of spent nuclear fuel to start building towards that large-scale transportation capability that we'll need in the future. All of this involves a lot of coordination with tribal, state, and federal partners. That's very important. We'll be eventually shipping from 74 plus different origins to multiple destinations, going through many state, tribal, local government jurisdictions. We need to make sure that we're working together and cooperating to keep these shipments moving safely and securely. We do that through cooperative agreements with multiple state regional organizations and a third party to support participation of what's known as the Tribal Radioactive Materials Transportation Committee. The department also has the National Transportation Stakeholders Forum, which is the primary mechanism for communicating with state and tribal governments about shipments of radioactive material. That's not limited to spent nuclear fuel. That includes all the departmental shipments of radioactive material. And then we have a lot of federal coordination as well. We have PHMSA and FRA, since we're planning to ship by rail. We engage a lot with naval reactors because they have a lot of experience transporting spent nuclear fuel by rail, and we collaborated on rail car development. We have coordination and lessons learned from other radioactive material shipping programs in the departments, and we have regular technical exchanges with the Nuclear Regulatory Commission, mostly for situational awareness, but also identifying opportunities where information sharing may be beneficial to both of us. I won't spend too much time on this because it's probably pretty small for you to read, but just wanted to highlight that we have all these projects are moving in parallel, and this is sort of the overall timeline. We have our siting effort at the top and the milestones currently planned for that project, which is, there's a high degree of uncertainty that the siting project is looking for willing and informed communities to host one or more federal consolidated interim storage facilities. So that is clearly kind of a delicate process. We're hoping later this year to go out with a request for expressions of interest to see if communities want to continue engaging with the department and consider it. We're working on the storage facility and capital acquisition projects, developing the transportation capability, conducting that package performance project in parallel. I do have to recognize that the Department of Energy is currently not authorized to construct and operate a consolidated interim storage facility. New authorization from Congress will be needed to do that. Right now, we assume that comes in the form of amendments to the Nuclear Waste Policy Act. There are other options out there. And then shipment of the hybrid research cask and possible other transportation activities. And just quickly, some of those other transportation projects we're looking at are our current shipment of the high-burnup research cask and the package performance project are expected to conclude in 2027, 2031, respectively. If the consolidated interim storage facility opens in 2038, that's sort of a 7-year gap that you have with maybe not any transportation activity. So we're having discussions about opportunities to do transportation demonstrations that might enable us to build out the transportation infrastructure, that's equipment, personnel, policies, procedures, coordination with state and tribal governments in that interim period. And that could include transporting commercial spent nuclear fuel, DOE spent nuclear fuel, high-level waste, maybe microreactors. We have a rail car. We're looking at all the options available. So we think this could be a good opportunity to keep momentum and keep building to that operations of the federal storage facilities. And I look forward to your questions at the end.
Thank you, Erica. All right, and our last speaker is Prakash.
Good morning. It's an honor to present. At the RIC, talking about transportation. My topic is going to be our readiness for next generation fuel and reactor transportations, and something that, a little bit about experience from Orano. I would like to just go a little bit about the advanced reactors and a special mention on the fuel cycle and how it impacts the back end, especially impacts on the back end and where transportation fits in. Obviously, I'll talk a little bit about our transportation activities, both domestic and foreign, but some experience regarding what we learned in France and how spent fuel has always been transported in France. And I'll give a little bit perspective, some technical, some regulatory, on the readiness for advanced reactor fuel. So, I mean, we all know that nuclear is really an essential piece of the fight against climate change, most importantly, giving us very good and sustainable sources of electricity and energy. Of late, there's been quite a large number of reactor designs, concepts being developed all over the world. And really, fuel cycle management for those, every reactor design is supposedly unique and more innovative than the other one. And with just 2 or 3 that we've been having in the last 40 or 50 years with B and PWR fuels only, it suddenly opens up a ton of possibilities and trying to figure out how we can manage that kind of fuel cycles. And therefore, fuel cycle management becomes pretty complex, especially the back end. So if there is solutions available for the back end, I believe that goes a long way in making these fuel cycles sustainable. So you must have seen some of these, but in general, obviously why there's a need for transportation in a fuel cycle, and again, a fuel cycle that could end up being very complex. And on the right side, you'll see a couple of graphics. One of them is supposedly an open fuel cycle, the other one is a closed. And in both cases, there are some decision points regarding, where to store your fuel. Is it interim? Is it on-site, or is it in a pool? And then once you make that decision about long-term, whether it goes to a repository for disposal, that's another decision point, or it stays in an interim storage facility, like Erika mentioned, or it goes to recycling, reprocessing, or any other treatment, and then goes back into the front end of the fuel cycle. That really is the and therefore, how that functions is all dependent on economics and availability of fuel, and the fuel cycle nature themselves. But what you see in the big picture is, transportation is very, very important. Whatever you decide to do, whether we store it in an interim storage facility or go to disposal, or store it on site and then go to disposal, or treat or recycle, transportation becomes a very, very important part of that fuel cycle. So that's where transportation comes in. And a brief about the transportation activities in Orano. Orano is a nuclear materials company specializing in transports. And we transport all over the world, front end, back end. We do natural uranium UF6 shipments. Most of the enriched uranium shipments are done in Orano packages. And then, of course, we also do spent fuel. So the breakdown is approximately 200 of the fuel shipments in Europe are all back in spent fuel shipments. And then out of the 2,500 waste and contaminated equipment shipments, those are, some of them are large vessel shipments, and that's what makes it relevant for using that model for reactor transports as well. From MTU perspective, again, Erika talked about the 3,000 MTU. That's roughly a large U.S. transportation cask is somewhere in the range of about 10 metric tons to about 18 metric tons. In France, it's always less than 10 metric tons. So we're looking at, if you're an average of 15 metric tons, then 3,000 MTU is about 200 shipments. So it's not an ambitious, and I'm just saying it's probably doable. And there is large amount of experience all over the world about transports of spent fuel. A little bit more details about how we do transportation in France. Again, it's a very large transportation program developed over several decades. So requires a lot of things to be in place. The three big pillars I call it. We definitely need the dedicated infrastructure, casks, and equipment. We also need the assets, which is your transportation assets. If it's rail, truck, and then. In terms of rail shipments, rail cars, which is great that we are also developing those, or have actually developed the most advanced, I believe is the most advanced rail car in the world. And then the terminals and other facilities to perform maintenance on the casks and equipment. And then, of course, as we want to keep up with the time and transports and obviously the public needs, the need for developing our resources, human resources, engineering, quality assurance, of course, and then communications. That all makes it a very expected type of transport situation, at least in France. And then as years progressed, I guess we also developed in France different types of cask models that have evolved over time. I mean, starting from the old casks that could carry 4 to 6 fuel assemblies to now to 12 to 18 fuel assemblies. The old TN1, 2, TN12, and now they have the TN Eagle and then TN Falcon, and then looking at about 70 kilowatts of heat that actually is being conveyed. And then, of course, another part of the transportation is the risk assessment. And it has been a continuous improvement in every shipment that we make. And then, of course, there are dedicated teams assigned for managing the routes, of course, supplying the suppliers, and working with our utilities, and then most importantly, managing crisis. I mean, it has not been event-free, but all of them have been managed very well. And then some of the lessons learned that are directly applicable here. What kind of lessons have been learned here? Event and operational data is critical, and there is a large availability of such data over 40 years of transportation. And the key is to maintain focus, primarily functional, permanent focus on safety, safeguards, and quality. Actually, also in the flexibility of the schedule, I mean, the reactor power operator needs are different, availability of terminals is different, and then, of course, the loading at a central terminal in France, normally, it's transported by train, goes to a terminal outside of Cherbourg, and then it then gets shipped from the train to a truck, and the truck actually takes it to LAG for reprocessing. So there is a bit of a operational handovers going on in that area, and then so we'll have to be very flexible in terms of maintaining that kind of a flow coming in day in and day out. And then as time evolved, they established training centers to train the operators, of course, to train the crisis managers, as well as to actually track the shipments. And most importantly, also have a very, very good communication outreach to the public. And then in terms of managing the crises, there is definitely a task force that is dedicated to effectively respond to any unscheduled events. Transparency is key, critical. The public expectations always, seem to go up. And then people have found a way. At least the Orano has found a way to really communicate that and drive down every bit of information that's readily disclosed to the public, and through outreach, through conferences, and also actually through general information sharing. We incorporate new technology where it's possible, available in doing our day-to-day business, as well as actually to communicate with the public. One example is on the right. I mean, obviously the availability of plant infrastructure, the plants are pretty old. And once in a while, with a new cask design, it becomes difficult to really understand the interfaces. So, we've developed a lot of virtual reality, off-site computer models, digital twins to be able to understand, all the clearances as new trucks or new infrastructure goes in to pick up fuel. We're also looking at, same thing. We have a prediction method for dose rates. So therefore, for any unscheduled events, we are able to respond effectively. Most importantly, the more recent things, updates that we've been doing is actually determining the dose rate or doses that public gets when one of these trains goes through a very crowded railway station. So there's always something going on so that communication is open and transparent and then very, very effective in advancing the cause. Let me switch to an experience that we've had for Crystal River reactor vessel transportation. It was done in the United States. It was done last year. Actually went from on a barge from Florida to Texas and then by road. The key highlight about it is it's the traditional way of segmenting the reactor vessel and then packing it into small containers and then disposing it off in facilities. Low-level waste facilities. And this was one example of where we decided to just ship the vessel as a whole into 3 or 4 segments. We segmented them into 4 large pieces. The key is the one that's we call the middle package, Type B, and it was 430 tons. And from a spent fuel cask is about 150 tons. So clearly, it was 3 times the size of a typical spent fuel cask. Over the TN32B that goes out. So again, it was accomplished without any event, took a lot of time, took 9 months from the first package to the last package to be disposed of in Texas. So again, we have done it in the US as well. So, and then there is there's a big, this gives a lot of confidence to, whatever type of fuel or whatever type of transportation we are planning, especially with spent fuel and radioactive materials. Just a quick on advanced reactor fuel transportation. As we move on, again, we talked about the regulatory needs. There is a lot of experience that's available from everybody all over the world, including Orano, in terms of fuel and radioactive material transports. And therefore, some of these packages can definitely be used. There's no need to develop a brand new set of transport casks. Everything depends on the contents, and if the contents can fit, I think there should be no issues with transportation. From an advanced reactor standpoint, obviously, in addition to regulatory requirements, there should be a need for additional technical evaluations because there are certain effects. I mean, I can say just one example, radiation effects on the geometry, especially if you're transporting spent fuel, in a reactor core, it won't be as easy as we think it is. I mean, thermal expansion, which nobody considered before, may become very critical in terms of maintaining the spacing and its impact on criticality. So just a few things, radiation effects on properties, especially differential thermal expansion between the vessel and the fuel actually can have a more complex impact on certain safety functions. In conclusion, transportation of nuclear materials is going to be a very critical part of the fuel cycle, particularly advanced reactors and fuels. We've had significant operating experience all over the world, and I believe which is directly applicable. And there do exist some technical considerations, but I believe the overall framework is available, both regulatory, technical, and whatever lessons we've learned from our experience can directly be applied to future transportation of fuels and reactors. Thank you.
Thank you very much, panelists. And I'll ask the folks in control of the slides if you can put the QR code back up. So if anybody missed it at the beginning of the session, you can ask them questions. We have received a number of questions, and I'll try to give everybody a little bit of love here. I don't want to leave anybody out. And I'll start from Prakash for you. And a number of questions just rolled in, so my screen, forgive me as I update. But essentially, the question is, what from an industry perspective, are you doing to prepare for the shipment in the future for advanced reactor type of fuels or other novel fuel designs?
So what kind of R&D or research that we're doing? Or-
Yeah, whatever you'd like to say. The question was
Yeah.
not specific to R&D, but just in general, your preparatory efforts to prepare for.
Okay, so,
fuels.
yeah, I think we've been doing some gap analysis, for example, between the materials, the radiation, as well as the compatibility of next generation fuel or reactors against the current generation fuel. The second one is most important, again, is the applicability of the current solutions is being examined. And between the two, again, we believe that, that if you have a good balance of contents versus performance, it is possible to use the existing solutions. Where certain reactor types we've seen where, like temperature is a big indicator, especially molten salts, it is clear that there is, it's very difficult to apply what we have right now. But on other reactor types and fuel types, we believe that the gaps can be addressed, and we are looking to see, how we can work with the industry and bridge those gaps.
Thank you. Erica, I've got a question for you next, and I've heard you speak on this before, so I think you'll have a good answer here. The question is, with the idea of public misconceptions about transporting fuels, what is the DOE in the communication space doing to build public confidence in the U.S.? And you touched on that in your presentation, but I think you probably have some additional details you can share.
Yeah, sure. Thanks for the question. We do many things that I touched on some of them in my presentation, but just to elaborate further. So our ongoing coordination with state and tribal government partners is very key. The model that's been put forward that's been successfully used elsewhere is when you have, say, community leaders, a mayor, what have you, if their chief of police, their chief of fire tells them, we're prepared for these shipments, we have the training we need, if there's an incident, we're confident we can respond, we understand the safety and security elements of this, then that gives leadership confidence, and then leadership can convey that to the general public. Providing information, commonly used tool is road shows, or in our case, we call it a whistle stop tour. So providing public opportunities for the public to come see your transportation conveyance, your packages, ask questions, maybe do open houses, just provide opportunity for people to come learn more. Providing that emergency responder training is a key component, and that's a model that the Department of Energy has used through the Transportation Emergency Preparedness Program, or TEP. We are planning to use that for our shipments as well. Providing advanced notifications to states and tribes, providing tracking technology, so state and tribal government personnel will have access to be able to track the shipment as it transverses their jurisdictions, and things like the package performance project. We plan to take high-resolution video and use that widely in public communication efforts to illustrate to the public what the robustness of these Type B packages are and what would likely occur in a transportation incident. So all of those pieces combined, as well as a robust public communication and engagement approach, is how we're planning to address public concerns on the safety of transportation.
Thank you, Erica. Matt, I'm going to ask you a question next, and it's related to your presentation today, and I anticipate you'd also have some perspectives to share from your role in the IEA Trans Committee. Does the DOT foresee any potential changes to our regulations? And I'll frame the question in terms of the international regulatory framework, the DOT, and of course, Brian, I'll probably ask you the same question about NRC. So for transportable microreactors, and the question is pretty broad and includes floating nuclear in addition to land-based transportable microreactors. So your thoughts about any updates to the regulatory framework that you might foresee?
Okay, thanks, Shana. Yeah, so as far as domestically, the U.S., we have one rulemaking that's currently has a notice of proposed rulemaking that's been there for quite some time, but I can say that the current administration is reviewing everything, and so can't make any statements on how or when that will progress or anything like that. But at the international level, The IEA TRANSC has been in a review and revision cycle since 2021, I believe, for SSR6. Again, those are the International Transportation Regulations for Radioactive Material. They were pretty well finalized at the end of last year in November. They're available. The current draft is available publicly online if you go searching for IEA TRANSC. And the biggest change with that right now is that the A values that I alluded to in my presentation have actually there's been a group calculating new A values since 2011 or so. And it looks like those will be included in the next revision of SSR6 at some point. Again, typically we harmonize with SSR6 at some point, and so you can anticipate that would happen at some point in the US, but I can't say when or how or anything like that. Specific to microreactors, transportable, floating, IEA is looking closely at it. They've held a number of meetings already, and I think they have some more on the books to see what's going on, but I don't know of any specific changes that are anticipated at this time.
Thank you. And Brian, is there anything you'd like to add?
Not really. I'll just say, possibly Shana knows something I don't hear, but my understanding is we're, of course, open to making changes depending on what kind of applications we get in. But in the meantime, we think our regulatory framework and the regulations themselves have enough flexibility with exemptions and whatnot that it can handle applications like this.
Thank you, Brian. And yes, I'll take advantage of my role at the NRC as the director of the Division of Fuel Management to say that I think that we are open to new ideas. Right now, I think a lot of folks have probably been hearing this week at the RIC about the ADVANCE Act and everything that we're doing to comply with the Act and look at fresh ideas and new ways of doing our business. So we're certainly open to that. I think the presentation that Brian gave about Project Pele and the paper that we shared with the Commission about how we might take a risk-informed approach, and the one that we did approve for Pele, that did not need any changes to the regulations. We can proceed with that type of novel approach under the current framework. All right, so let me go to a number of other questions. Erica, you're popular. The question is, does the Department of Energy have any plans or know of industry plans to recycle spent fuel prior to transport to long-term storage?
There certainly have always been ongoing discussions about recycling or reprocessing. Within the Office of Nuclear Energy, the Office of Fuel Cycles is the office that conducts research and activities related to recycling and reprocessing. For our program, our authorizing language is principally the Nuclear Waste Policy Act, which includes storage, transportation, disposal of spent nuclear fuel and does not include recycling or reprocessing. So at this time, our program is not focused on those. However, there's certainly compatibilities there. My boss, Paul Murray, likes to say that one of the first steps, if you're going to reprocess or recycle, is collecting all the spent nuclear fuel in one place. And so a federal consolidated interim storage facility would do that, and that may provide an opportunity for industry or other entities interested in standing up recycling or reprocessing capabilities to potentially co-locate. But that's not, that would be sort of a separate initiative, and that's not something we're including in our siting efforts at this time.
Okay, thank you very much. Erica, as I mentioned, you're popular. And there's a question about the timing of a consolidated interim storage facility. The person asking the question noted that in years past, we've had different timelines for consolidated interim storage. At one point, we were looking at having something in place by 2020. And so it's a question about the confidence that you have and the timeline that you shared with us today.
Sure, yeah. Certainly, it could be said that, federal government in general and Department of Energy has never put a timeline out there that it hasn't, ultimately run right past. So there's certainly a risk. The schedule for opening a facility in 2038 is a schedule that we believe is achievable. However, it does depend on several external factors outside of DOE's direct control. So we need authorizing language from Congress, preferably sooner than later. We need adequate and consistent resourcing. We're in March. We don't know what our FY25 appropriation is going to be. That makes it challenging to operate multi-decadal or 100-year plus programs efficiently. Changes in administration. We are awaiting guidance from this administration on whether, the planned path forward is this administration's path forward. So there's a number of factors that certainly challenge schedules and especially large capital acquisition project plans. We had a number of plans to start procurement activities this year that are currently on hold. So it's possible that that schedule could end up being delayed. It's possible that it could be accelerated. That schedule assumes we identify a site and have a binding agreement with the site to host a federal interim storage facility in 2031. The department has been contacted by many communities thus far that are very interested and they want to move faster. So there is, it could happen earlier, it could happen sooner. It's subject to a number of factors, some of which are within the program's control and some of which are not. So I'd say that's our current plan, and we'll adjust plans as needed.
All right, thank you. Prakash, I'll turn back to you. You talked about the Crystal River reactor vessel, and the question is, how are those vessel segments transported between the port in Texas to the disposal facility?
Yeah, for the Crystal River segments, they were transported from the barge terminal all the way to WCS by truck. So it was a very slow shipment and required several permits, road permits, and in some cases, I think the last one took almost 3 months to, travel the final 100 miles or something like that. So.
Thanks, and I'll stay with you for the next question, which is sort of a follow-on, which is a question about, can you explain the process of communicating with the various stakeholders in the region that you're passing through during the transportation of nuclear materials?
Okay, so in the U.S., So really, we've conducted about 8 shipments from Vermont Yankee to WCS, and then the one from the Crystal River. And out of those, one of them was a pretty, I would say, a big involved safety security type shipment that was the last shipment from Vermont Yankee that involved 6 states. So we had to be in communication with all the states, and the routes had to be determined in advance and communicated to not just the states but to the counties as well. So the communication process, we also had a transport provider, so it was basically Orano, the transport provider, and the states, and then the repository or the disposal facility receiving it. Shipments were largely uneventful. We did not see any issue at all. And then the handovers between the counties, between the security administrations was extremely smooth. There was sufficient time for communication, and the communication, obviously written down, so we do actually have a lot of procedures that we developed in this process. We haven't done a spent fuel shipment yet. I believe that this will be employed, I think, largely to also develop our communication for the high burnup demo package as well.
Thank you. Matt, I'll come back to you. And there's a question about what does DOT do to compile and share information? And I'll take the question was specific to the number of people harmed annually due to the release of transported hazardous materials. But I'll broaden the question and say, what type of information do you make available to the public when it comes to the transport?
No, that's a great question. I'll say, so we very closely try and follow any radiological incidences and work with our team of investigators, and we have an accident investigation team to monitor the situation. But we do have, the main tool that I can think of at the top of my head is there's a tool called the 5800.1 form. It's available on the PHMSA website. It's a regulatory requirement for any hazardous material transporter to report to DOT any incidences that there's a laundry list of things that trigger that form across all different forms of hazmat, but a radiological release is one of them that would certainly would trigger that form. So we do that. We also share information with the NRC and follow your databases as well. But I will also say that there's a very long-standing history of safe transport of radioactive materials to where overall we've been very fortunate that it's very rare to have an incident that is of significance. So that's a positive thing.
Agreed. Thank you very much. Let me see. There are a number of questions coming in. And once again, I apologize because I don't believe we'll have a chance to get to all of these questions. So one thing that I would like to pose to the panel, because this is focused on advanced fuels, and before we run out of time for questions, and we'll just go down the line. I'll start with you, Brian. In your opinion, as we're looking to the future of transporting novel fuel designs on the front end of the fuel cycle, on the back end of the fuel cycle, what drives our work? Is it more of a technical challenge or more of a policy challenge as we go forward to make sure that we've got the framework in place to safely transport? Yep, you need that.
I would think it's mostly a technical challenge. I think the policy framework, guidance, regulations we have in place are generally, maybe not always, but generally flexible enough to cover advanced fuels, new and advanced fuels. But it's just, there's not the operational basis, not the history, so the technical information just needs to be developed.
Thanks. Matt, same question for you.
Sure. So I think this is kind of building on what Brian's saying, but I think the biggest challenge right now is just the unknown. There's a lot of designs that are proposed out there. There's a lot of different scenarios where these things could be used, but there's not the technical data behind it yet that I'm aware of that says this is exactly what we're going to need, and this is what we need from the Department of Transportation in order to transport it. And so just having that better defined so that we can then react and respond and help support transporting this material safely in the future is what we really need.
Erica, yes, your thoughts?
Sure. So this came up in our office a couple years ago when some of these reactor designs started to be in discussion. And so our office stood up an integrated project team comprised of experts from within the department and our DOE's national laboratories called Back-End Management for Advanced Reactors, or BMAR, if you've heard of that, to look into some of these questions on advanced fuels, and engaged with reactor vendors and requested information on what their spent fuel forms would be to compare it to kind of conventional light water fuels to better understand how they would be similar or different in terms of storage, transportation, and disposal. And in general, for storage and transportation, we find no technical issues. For disposal, there are some ongoing discussions, especially where fuels may have RCRA materials like sodium. There's some questions and discussion about volume of TRISO fuels and whether treatment may be the preferred approach prior to disposal. So those are ongoing discussions. We didn't want to get too far, out ahead of our skis in terms of there's many designs. I think somebody had a slide that was, I think I've heard there's 60 different designs out there. We don't feel like we need to analyze all of them. We'll wait for the ones that are, maybe submit a license application before we focus too much. But we have looked at this, and for storage and transportation, no major issues. For disposal, it's an ongoing discussion.
Thank you. Prakash, your thoughts?
I'm from the industry, so the industry has had an excellent record. I think if the framework is in place and a few experiments or tests or a few times we stutter, but in the end we end up doing an excellent job. So if some of the regulatory and technical issues, if whatever they are, being identified, and in the end guidances are developed or guidances do exist, but if the guidances are more clarified, I think the industry will respond And it is quite possible. I mean, we've done quite a bit of work with the light water fuel, and I think systems that have been developed, processes that have been in place, and operations that have been perfected, at least for the storage, I think can be extended for transportation as well. So the actual package design, as well as the physical transportation, and all the communication that goes within, I think can be improved significantly. But I don't see an issue for the industry to adapt and actually stand up to it. So I believe that it will be a collaboration effort. As Erica said, I mean, if some of these items are identified and codified and boundaries drawn, I believe it'll be just the operation. That'll be a boring operation for us to do.
Thank you. I think we have time for a few more questions, and I want to make sure I give everybody the break between sessions. But Matt, I've got a question for you, and the question is, what does DOT see as the difference between mobile versus transportable reactors, and what does that mean for creating and implementing regulation? And I think what the questioner might be asking is the difference between a reactor that's in operation during transport versus a reactor that may be not in an operating mode while it is in transport and then transported somewhere and operated there.
Okay. I think, so let me think of how to address this. It'll certainly be a challenge as far as we've transported, between the NRC and DOT, there's been a history of transporting spent nuclear fuels and stuff like that. But anything either active, and I will say there's one thing that our regulations specifically do not cover. If it's something that is incident to the use of the vehicle. So in other words, like if there's a nuclear powered vessel, that falls under a different category than if there's a reactor being transported on a vessel. So those are two separate things. And those are some of the things that are being talked about that really need to be worked out. So that is one of the challenges. As far as defining mobile versus transportable, again, that's one of the things that we're looking to, and we talk to the industry to try and find information. What can you do within the regulations right now versus what needs to change? And so that's one of the things we're looking to see, because I think we're still in the early stages of that. And we need to understand what needs to change on our end so that this can be transported safely, if that makes sense.
Yep, thank you. Erica, the question is addressed to you, but Matt might have some thoughts on this one as well. Most of the baselining for rail transport of radioactive materials is against the European experience. However, in the United States, the rail lines are privately owned. How does this affect future outlook of the DOE's intention to ship through the rail system? Sure. I think what the questioner is asking is most rail transport, it kind of follows the European experience, and I think it's implied that perhaps in Europe there's not private ownership of the rail lines, but in the U.S. there is. So how does the private ownership affect the transport?
Okay, that's an interesting question. I'd say there's a key difference in the U.S. So yeah, that's true. In the U.S., the freight rail infrastructure is almost universally privately owned and operated. However, rail carriers are known as common carriers in the U.S. So under U.S. regulations, if a shipper offers a package for transport and it is packaged in accordance with DOT regulations, a shipper cannot refuse that transport. And so that's a little bit of a unique situation that we have in the U.S. I know in Canada they don't have that, and I think there's more challenges with rail carriers not wanting to transport hazmat in general. But I think in the U.S., one key difference, and maybe Prakash can chime in because he has experience in the European shipments, just at a high level, my understanding is European rail, the priority is for passenger transport, whereas freight rail is secondary. In the U.S., you have the reverse. The priority is for freight rail transport, and the secondary is passenger. So it is true to say that rail carriers in the U.S. are not necessarily enthusiastic about our shipments, in part because they'll attract a lot of potentially negative attention, require extra safety and security handling, and are going to be, not thousands of shipments every week. That is a huge part of their business model. But that said, they do understand that they are obligated as common carriers to accept these shipments. We do engage with the AAR and rail carriers and talk about how this is going to work. In history, we've been sort of onesie-twosie type shipments, and the high burn-up research cache will be one of those. And then in the future, we'll have much more frequent shipments, maybe on the order of one shipment a week is what we're projecting. So that will be a different model for sure. But we do have in the U.S. Navy has been shipping their spent nuclear fuel from naval reactors by rail for, I think, going on 60 years now. They have fewer shipments than we expect to have, but it's still a very robust model, and we plan to basically copy a lot of what they've done to implement in our shipments. So they've been able to do it. We have no expectation that we won't be able to do it. Well, it'll certainly be something that we have to coordinate with the rail industry and with the regulators. But we see no significant differences. And Prakash, I don't know if you see any differences from your experience.
Yeah, I mean, there should be not a lot of difference on the macro scale, but just focusing on France, though, it's a smaller country. The routes are much more specialized, and I believe that that makes it much more systematic study. In terms of U.S., I guess the vastness of the country and the probably relatively small number of radioactive shipments versus the rest of the freight makes it a little bit of a challenge, achieving some real long distances. But overall, it should be very much doable.
Great. Anybody else have any perspectives? Matt?
Yeah, Erica covered it really well, but I think Federal Railroad Administration does a really good job of closely keeping an eye on our railroad systems and have a good relationship as far as communication with all the various private owners of the rail. And so I agree that the system works well. They're familiar with transporting radioactive materials, so I think the communication line's there. I know I've sat on meetings with Erica and Federal Rail and ourselves on at least a couple occasions already that, this is all being talked about, and I think we all can work together on it.
All right. Well, that's a great note to end on. I appreciate the sentiment about working together, and appreciate everybody who is here in the session today. And I think we hopefully did not go over our time, but I think we're about out of time for our session. So thanks very much to the panelists. I'd like to give you a big round of applause for making this an interesting and productive discussion. All right, thanks everybody. Enjoy the rest of the RIC. And please don't forget to give some feedback on the session.